Ladies and gentlemen, this is lesson number 25 of the Databases in SQL video tutorial course. Now, we're going to be talking about indexes today, and indexes is one of those topics that you can definitely go on about for many, many hours. So this is going to be a fairly brief overview of the topic of indexes, because like I said, you can really spend a lot of time on this, and that kind of goes against the whole scope of this course. This is more of a breadth, first type course where we go through all the topics and introduce them to you, and then if there's any one topic that really, really resonates with you that you really want to dive into, you absolutely can. There's certainly a lot of great resources online, especially through YouTube videos that are all about indexes and teaching the ins and outs of indexes. So here's what you're going to learn today. You're going to learn about what an index is, what it's used for. You're going to learn about the different kinds of indexes that exist within MySQL and the advantages and disadvantages of using indexes. So let's get started. So the first thing is obviously, what is this thing called an index? What is a database index? Well, an index is used to speed up queries on tables. So you can imagine, being in a situation that you have a table, let's say our transactions table, has like over 5 million records in it, okay? And even when you get into typical high volume type situations, type systems, applications and whatnot, 5 million records is actually not a lot of records at all. I don't know if I've mentioned this before, but I worked at a company that I believe had somewhere close to, I don't even know how many millions of, it was probably like close to 500 million transactions in one of their tables. And it just becomes very unwieldy. It becomes very crazy to deal with that volume of data, and it's all important data. You need to be able to use that data, and it needs to be able to work inside of your system. So that's where indexes really come into play. It's when you're dealing with, I guess you can call it quote unquote big data. Okay, when you have lots and lots of data, that's when they really shine and when they really give you the biggest bang for your buck. So let's say we have a transactions table with over 5 million records in it, and we need to do something like a query for all transactions greater than $500. Or we need to, group the transactions by transaction type and return some information about that. Or maybe we need to find, any transactions that are exactly, $1,000 or $998.58 or something like that. You need to find that one transaction that's exactly that amount. So if you're in any of those types of situations, all those different operations take a fairly long time without the help of an index. And when I say fairly long time, I'm talking about, on the order of, what was I seeing? I think I was seeing something like 30 seconds. Okay, so 30 seconds when you are dealing with one database query is actually quite a long time. Okay, you can imagine, let's say you're loading up a website and you need to wait over 30 seconds for the website to load. What's going to happen? Well, we have such short attention spans these days that we just will bounce right off and go somewhere else. Okay, so, but if you're in a situation where you're using a piece of software that you need to be using and you just can't, leave because you've lost interest, you absolutely need the information that you're going towards or going to get, then, you have to wait 30 seconds, and that is, believe it or not, painful, especially if you are in a situation where you need to hit that page many, many times, okay, throughout the day. So that can get very annoying. So that's what indexes are for. Now, MySQL, the MySQL database system, must perform something called a full table scan without an index. So a full table scan means that if you are, let's say, searching for all transactions that are greater than $500, MySQL has to go through all 5 million rows in the table, or over 5 million rows in the table, and go through them one by one by one by one, and find any that are greater than $500, and then, return that as a result set back to you. Okay, that is obviously annoying. That is a worst case scenario, going through and scanning the entire table. Whereas with indexes, you can dramatically reduce the number of scans that are needed, the number of rows that are looked at and processed can be reduced with the use of indexes. So let's talk about how that goes about happening. So an index is kind of like having another table in your database that stores information that helps us search for our information faster. Okay, so it's just like having another table. In fact, I'm pretty sure that's what it does, is it creates a different table, only it's not a table that you can access in any way, shape, or form. It's not like a view where you're kind of creating this imaginary table, and then you can read from it yourself and sort of interact with it yourself and see what's going on behind the scenes. When it comes to indexes, you can't really see what's going on behind the scenes because that's what's handled and sort of abstracted away from you within the MySQL database system. And not just the MySQL database system, but any relational database management system will sort of hide that away from you. So in any case, let's take a look at some of our transactions and our transactions table. So as it stands right now, I just grabbed a snapshot of some. We have transaction IDs 1 through 16. I'm missing transaction ID 2. I'm not sure why. Maybe I deleted it. Who knows? They have transaction dates, amounts, transaction types, and a bank account ID that they are related to. So as you can see here, if we wanted to query this table, if we wanted to look through this table for all transactions that were greater than $500, what would we have to do? Well, like I said, if there's no index, it has to do a full table scan. Now, this is only, 15 different rows to scan, so that won't take long at all. But if you can imagine that this was, over 5 million rows, then you can see how this would take a while. So it goes from the first record and says, okay, is this first one greater than $500? No. Goes to the next one. Is this one greater than $500? Yes. So then it'll take the transaction ID, the actual key, the primary key that is used to identify this row uniquely. It'll take this and put it somewhere for later for later use. It's going to use it to return this particular data set back to you, right? So that's going to be on queue to be returned back to you. And then it goes to line 3. Is this greater than 500? No. Greater than 500? No. And so on and so forth. And it scans each one until it finds, this one, ID 14 will be put into our queue, and ID 15 will be put into our queue to be returned back to the user. And then as a user, as an end user, what we will see is we'll see 3 transactions pop up. You'll see transaction ID 3, 14, and 15, and there you go. So now we can confidently say that we've gone through and we know that we have hit all the records, and we know that those 3 are the only 3 that are greater than $500. And that's the end of our operation. That's the end of our process for searching for those 3 records, or rather X number of records that are greater than $500. Now, again, you can see how that would take a long time. So let's introduce an index. Let's put an index on the amount column. I'm not going to get into the syntax just yet. I just want to get you to be familiar with the process that it goes through to actually index a column. So let's say we've created an index on the column. What does it do? So what it does is it takes the amount column, it will go through every single amount, and it will create an index in sorted order. So essentially, you can think of indexing almost like sorting. Okay, it depends on the index that you use. We're going to get into the types of indexes later in this lesson. But for this particular case, what it does is it just sorts the data. And what it does is it sorts it in a special manner. It sorts it in ascending order on the column that you've chosen to index, and it also keeps track of the primary key for the associated row. Okay, so you see what happens? It takes, this is the least amount row, it puts it at the top, and 181 refers to transaction ID 4, which when you look over here, look at transaction ID 4, you see that that's amount 181. And then we have 515, which is a transaction ID 5. We go to transaction ID 5, sure enough, it's 515. And 699 is transaction ID 6, and so on and so forth. So now we have this in sorted order. So now when we say, okay, I would like to grab the transactions that have an amount of greater than $500. Now it can apply a smarter searching technique to find the actual amounts in play here. Instead of doing a full table scan, it can apply whatever logic or whatever operation it needs to use, or rather it uses, to search for something. Now there's a whole bunch of different searching algorithms. I'm not exactly sure which one it uses, but an example of what you could do is you could split it in half. You can kind of do a binary search, split the records in half, and look at the record that you get. So maybe this is about halfway point. I don't know. I'm not sure, but maybe $100 is about the halfway point. And you say, okay, is my amount that we're looking for greater or less than $100? It's greater. So we know that the records that we're looking for are after this row. So then it takes the rest of the rows and says, okay, let's split that in half. So the halfway point is, I don't know, about maybe here, 488. And then we do the same thing. Is 488 greater or less than the 500 that we're looking for? And so on and so forth. And then it can split it in half and do the same thing. That might be one way that it goes about doing the search. Again, I have no idea what algorithm it uses, but the point is, it is much faster for finding the appropriate rows. Because once it finds the transaction that's greater than $500, then it just has to go and return all the rows below it. Okay, so instead of having to do, whatever it is, 15 different scans, 15 different operations, it can maybe do, whatever that would be. It's, I forget now the sorting and searching methodologies. If it's like, n log n time or something like that. If you're familiar with the big O notation, I believe it's n log n, or maybe that's sorting. In any case, that will be far less time that it will take to find the records. Okay, so that's the whole point of an index, is to sort the data or massage the data in some way, shape, or form that it will make it easier on you to find what it is that you're looking for. Okay, so now what you can see here in this slide, I just am reiterating everything I just said. I didn't realize I created a slide that goes through everything I just said, so I can go over it briefly. I can say, with an index on the amount column, you see how it sorts all the values, again, in ascending order. It sorts them, and then this allows you to search much faster, because when you have sorted numbers, it's much easier to search through and find data with sorted numbers. And now it'll obviously be easier to find the amount greater than 500, or even the amount equal to, let's say, 188.15, for example. Okay, again, through searching, it will be easier to find that figure because we know we are in sorted order. Excellent. So now that we've sort of talked about the advantages of using indexes, in the next lesson, part 2 of this 3-part series of a lesson, we're going to be diving into the disadvantages of using indexing, because there are disadvantages. We're going to talk about when specifically you should use indexing, and we're going to look at some of the examples, some of the types of actual indexes that we can make use of inside of MySQL. So, looking forward to seeing you in the next part number 2. So I will say bye for now.